Hello everyone, this lecture will be on multiplying and dividing fractions. Starting off with multiplying fractions. All you're going to do is multiply across. So if you have the fractions a over b times c over d, the result will be a times c over b times d. So all you do is multiply across. And then of course you want your most simplest fraction possible, or your fraction in lowest terms. So if it's possible to reduce, then you would do so. So when I look at 2/3 times 9/8, I will handle this one of two ways. The first way, or I could handle this one of two ways. Like I mentioned, I could just multiply across. 2 times 9 is 18. 3 times 8 is 24. Then look to reduce them. 18 is 6 times 3. 24 is 6 times 4. 6 is canceled. That leaves me with 3/4. So I'll multiply it, then reduce. The other way is to reduce first and then multiply, which is the way I would suggest that you get used to doing this. Because if you're dealing with very large numbers, what you don't want to do is multiply these numbers out and then be dealing with unfamiliar numbers that you have to break down when you could break them down when they are familiar. So what I mean by that is 2/3 or 2 over 3 are prime numbers, but 9 is 3 times 3. 8 is 2 times 2 times 2. When it comes to multiplying fractions, notice that 2 times 9 was the 18, so 2 and a 9 stayed in your numerator. 3 times 8 is 24, so all of the 3 and the 8 was in your denominator. So before you multiply, if there's anything that can cancel out, and this is only for multiplication, if anything cancel out with the top and bottom before you multiply, no matter where it's located, as long as it's in the top or in the bottom, you can cancel them out. So if I have a 2 here and a 2 here, I can cancel those out. This 3 and this 3 can cancel as well. And don't forget that if the whole thing cancels in the numerator or denominator, you're left with just 1. So I have 3 over 2 times 2 left, which is 3 over 4. So once again, I would suggest that you get used to trying to do method 2, so that if you're dealing with very large numbers like you will see in a few, you'll be able to cancel out before you multiply these numbers. So let's look at a few examples. And I'll probably just say something like multiply the fractions, something of that nature. So here we have 2 over 5 times 4 over 7. They don't have anything in common. So you would just multiply across. 2 times 4 is 8. 5 times 7 is 35. And then cancel. And remember what we talk about, what we mean when we say have anything in common. It goes back to our last example. Is there a factor that can cancel out with the top and bottom and reduce? So that's what we mean by having anything in common. Here we have negative 8/3 times 5. That 5 is the same thing as 5 over 1. Multiply across. And that is negative 40 over 3. Always check to make sure your answer is in lowest terms. You are expected to do that even if it doesn't say. So from this point forward, once you learn about lowest terms, they are expecting you to write your answer in lowest terms. So here we have 4 over 30 times 5 over 14. So here's where you would start writing these numbers as prime numbers, or at least if you don't write it, you're processing that in your mind, so you know what, so that you know that you have to cancel out something. So 4 is 2 times 2, 30. 6 times 5, and you can break up that 6 into 2 times 3. So that's 2 times 3 times 5. 5 is 5, it's a prime number. 14 is 2 times 7. So now I can cancel out numbers that are in common with the top and bottom. 2 over 2 cancels, and then it's 2 and 2 will cancel. Also 5 cancels. Everything cancels out in the numerator here. Everything cancels out in the numerator here. So I'm left with 1 on top, 3 times 7 on bottom, so that's 1 over 21 as your final answer. All right, same thing here, 10 over 18, 21 over 55. So 10 is 2 times 5, 18 is 2 times 9, and that 9 is 3 times 3. So it's 2 times 9, 9 is 3 times 3. And 21, 3 times 7, 55 is 5 times 11. All right, so we can cancel out 2's. There's a 3 here, and a 5 here. On top, we have 7. On bottom, 3 times 11. That'll be 7 over 33. All right. So let's look at division. Before we do that, they do mention reciprocals. And that's just the flipping of the fraction. So if I have 2/5, the reciprocal of 2/5 is 5/2, so 5 over 2. If I have negative 10 over 7, reciprocal of that would be negative 7 over 10. If I have 8, and that reciprocal would be 1 over 8. And that's because any number by itself is that number over 1. All right. Oh, also, put this note right here. I can write it. 0 does not have a reciprocal. Because if you have 0, that means the reciprocal will be 1 over 0, which is undefined. So don't forget, you cannot divide by 0. Okay, so the reason why that is important is because whenever you're dividing by a fraction, you're actually multiplying, or you will actually multiply by the reciprocal. So whichever fraction follows the division sign, you're going to have to flip it and then convert that to multiplication. Some people like to say keep, change, flip. So you keep the same fraction the same. Keep the first fraction the same. Change the division sign, then flip the fraction. So keep, change, flip. Keep the same fraction. Keep the first fraction. Change the division to multiplication, and then you flip the following fraction. Once you convert it to multiplication, then you just follow all the multiplication rules. But you cannot follow the multiplication rules until you actually legitimately convert it to to multiplication. So in other words, if we go back to 2/3, before we had 2/3 times 9/8, so this time we'll do divided by 9/8. Before we could reduce because we were already in multiplication. This time we can't until we convert it to multiplication, and the only way we can do that is by keeping the first fraction, changing the division to multiplication, and flipping the second fraction or fraction that follows the divisional sign. Now we recognize that we cannot reduce anything, so we would just multiply across. 2 times 8 is 16. 3 times 9 is 27. So that's how you will do your multiplication, your division. All right, so let's do a few examples and then we'll close it out. So here we have 2/5 divided by 7/4. 2/5 times 4/7. Keep the first fraction, change the division sign, flip it. Flip the second one. Multiply across, that's 8 over 35. Here we have 2 over 27 times negative 15 over 8. I should have given myself more room for this one, but it's all good. That's 2 over 3 times 3 times 3. Yeah, I'll go ahead and erase these, bring them back. They're trying to force it. So that's 2 on top. That 27 is 3 times 9, so it'll be 3 times 3 times 3. 15 is 3 times 5. 8 is 2 times 2 times 2. 2's cancel. 3's cancel. So on top, you have negative 5. On bottom, we have 36. Thirty-five over 14 divided by 7, so that's 35. I'm going to stay red for my answer work. 35 over 14 times 1 over 7. 35 is 5 times 7. 14 is 2 times 7. that 1 over 7. It's just 1 over 7. So that 7 in the top can cancel out with any of the 7s down bottom. Doesn't matter which one. So you have 5 on top. That's 5 times 1 on bottom. 2 times 7 is 14. All right, we'll do one more. So that's negative 12 over 1 times negative 3 over 8. Keep that same first fraction. Remember, 12 is 12 over 1. Division, change to multiplication, and then negative 8 over 3 turns to negative 3 over 8. Break them down. So 12 is 2 times 2 times 3. It's negative 3, 2 times 2 times 2. And don't forget, you don't always have to break it down to prime numbers. If I wanted to break them down to 4 times 3 for the 12, 4 times 2 for the 8, could have done that. We just want to make sure everybody's okay and everybody's with me. So the 2's cancel. 2 2's cancel. Also, you have a negative times a negative here. They're going to cancel for us. And that leaves us with 3 times 3 on top, 2 times 2 on bottom. So that is, oh, not 2 times 2, sorry about that. Just 1 2 is left on bottom. So that should be 9 over 2. All right. So try this stuff out. See if you have any issues. I see one more that's a good one. We got negative 10x squared over y squared divided by 5y. So that negative 10 is 2 times 5, x times x, y times y over 5. 5's cancel. One of those y's will cancel for us. And that would be negative 2x squared, because of x times x, over the y. All right. So try the stuff out. See if you get stuck. If you have any questions, feel free to email me. And that is it for this section. You guys have a good one.